getting warmed up. Literally, tomorrow is going to be up to 34 degrees, I believe. Currently, it's 14 here in Narre Warren South. We're broadcasting on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, lower sideband, and also on the Melbourne television repeater in full HD, thereabouts anyway. VK3 RTV digital channel 1. Good evening, viewers. And also on the Discord channel. I've mentioned this numerous times, so get with it. Give YouTube away. It's too slow. But nevertheless, register with Discord. Simple thing. No fees. And then I provide a link to the Discord channel on the qrz.com page, VK3EKH. But we are running YouTube nevertheless, 20 seconds delay. So if the YouTube stream doesn't fall over because of RF getting into things, then YouTube is the next chance to see tonight's missions, where you'll find the vision on the, if you just type in VK3CSJ in the YouTube search engine and look for the live indicator, and you'll see the YouTube stream. There's plenty of images tonight, including a quick solar report from Tamitha Scove, our space with a woman, who did a presentation down at Hobart last week at the Reist get-together, via Zoom, I should say. And, well, at least I think it was Zoom. And we saw a short presentation of that presented by John VK3ATV on the Tuesday ATV net. If you're not receiving ATV, get into that too. If you're within range of the ATV repeater, which is located just behind the police academy in Wheelers Hill, running over 100 watts of DVB-T2 in almost 360 degree coverage, you should have a good chance of seeing the TV repeater direct. Any information, more information about RTV, there's two websites you can go to for more technical information on RTV. VK3RTV.com, and also at the Amateur Radio Victoria website, ARV. Not sure of the URL right now, but if you just type in Amateur Radio Victoria, there's a dedicated page for RTV. All the information you need to be able to see it. Which reminds me, I'll be hosting the ATV net next Tuesday night at 8 o'clock, so be there or be square. All right, for those going down to the Rosebud Hamfest on Sunday morning, have a good time. I won't be going, but it should be a good day for all those making the trip down to Rosebud, so I'll be thinking of you. Time is 10:06 here on the 15th of November. Where else am I? Oh yes, YouTube, I've mentioned that. There's an email address, vk3ekh@gmail.com, vk3ekh@gmail.com for any correspondence to tonight's business. I think that's about it. All right, we'll see you all next week. Thank you for joining in. All right, let's get into... oh, yes, that's far down the track. Right, a little bit of information about the Society for those that don't know. In fact, this weekend is this weekend? Is the Star BQ? The Star Party. I think it's this weekend. The ASV is a non-profit society for people interested in astronomy. attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. It was first formed in 1922, and the society has grown to well over 1,600 members scattered about the country and overseas. The activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. Just waiting for the TV repeater to kick back in. There it is. Yes, occasionally the repeater likes to reset itself. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village, which I haven't been to yet, I'm not really sure where that is, and the Melbourne Observatory. And the ASV host monthly Astro Talks, as they are now known, at the Herbarium near the Melbourne Observatory. And last Monday, the ASV conducted its Astro Talk, which had Dr. Sarah Webb. In fact, I might rerun that presentation after this session tonight on our video medium. But it was most exciting, most interesting, I should say, most fascinating, Dr. Sarah Webb, talking about the end of life of the Earth, more or less. Anyway, so yes, the Society's library is also located at the Melbourne Observatory and is open during our Astro Talks, or the Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. And our members conduct astronomy for the people get-togethers throughout the year, bringing telescopes. What's that noise? I'm hearing a noise from somewhere. It's a funny noise. Where is that coming from? Most peculiar. Not sure if that's outside or inside. Funny noise, but at least seems like I'm still on air. Where was I? Bringing telescopes and astronomy to Melbourne's parks and schools. If you want to find out more information about these public get-togethers, which, like I say, the public can join in on, just check the calendar of events on the events tab on the ASV website. The ASV is currently involved in a number of major projects. They are involved in the restoration of the Great Melbourne Telescope, an ongoing project now for many years, and still probably about another 3 years before that telescope finally gets relocated to its old home at the Melbourne Observatory so the public can see it. After its devastated damage caused by bushfires up at Canberra a few years ago, many years ago. The ASV is currently involved, yes, I've said that. We are involved, yes, I've said that. Currently working on an installation of a series of remote telescopes at our dark sky site, which once complete will be accessible to members for their use. Thanks to generous donations from one of its long-standing members and respected members, the Leon Mao Dark Sky Site, LMDSS, is located just north of Melbourne, north of Heathcote, and has pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope located at the site, and makes use of the existing telescopes at the Melbourne Observatory during section meetings, which members' nights held once a month at the observatory. An annual yearbook is supplied, and I think I've got that just in reach here. Just a sec, stand by. I'll just get this yearbook because I haven't really shown it for a little while now. But that's the yearbook that ASV publishes annually. And I'm on the wrong camera, am I? Yep, there we are. And it's quite a decent publication. It's kind of like an almanac of sorts for astronomers. So it's a decent publication. I'll show you a very quick flick through the pages. There it is. And I think you find that just getting that is worth membership to the society. I haven't had any coffee yet, so let me have that so I can keep on going. Righto. Where was I? So that's the yearbook. The ASV's logo. Let me show you that. I can show you that. Let me go to Cameron 2, because that's where I thought I was before. That's camera 2. So that logo that you can see on screen as we speak, although it doesn't have the Latin in it, but the text that I'm reading from says that the ASV logo shows the Southern Cross and the pointer stars, which is... Oh, I'm on the wrong camera still, am I? I know. Hang on a sec. Where's vMix? Do this, Clint. There we go. All right. I really do need a camera person here. But anyway, that's the logo. And there is a motto in Latin, and I can't pronounce it. I don't know how you pronounce it. Sic iter ad astra, which is translated as this way to the stars. So isn't that nice to have something like that? The ASV is governed by a set of rules, and anybody who's a film buff like I am would know where I get that little expression from. Rules. Where do I get that from? I'm thinking of Bruce Willis's film Die Hard, but I'm not sure if it was that film now, actually. Rules. There are rules that police follow. Yeah, I think it was Die Hard. Doesn't matter. So anyway, the ASV is governed by a set of rules which should be read before applying for membership. And of course that document apparently is downloadable from a link provided on the website, but I don't think that works. All right, any person or organisation with an interest in astronomy is more than welcome to apply for membership to the ASV, which you can do via the homepage. And it's all done via PayPal. Easy peasy, Japanesey. Yeah. All right, I'm really filling up the first 15 minutes here. Now, the Astrofest, which was just the other week, turned out to be quite successful, I believe. I haven't heard final results of that yet, but I believe it was still it turned out very, very well for the folks that went up to participate with the Salt Lake location northwest in Victoria there. But this weekend is... No, hang on, I just lost that. I just lost it. It was just on the picture there. It is Saturday the 30th of November is the Starbecue. So it's not this weekend. What else was happening this weekend then? Don't know. Anyway, the Astronomical Society's third big event for the LMDSS is the Starbecue, and it is being conducted on Saturday the 30th of November. So book now. If you go to the ASV website, you'll find out more information about all that. It is open to the public as well. So, but you still have to register as such. You will have to buy some tickets, and so they normally get about 200 to 300 people up there. The The ticket gives you access to the LMDSS for the duration of the ASV's Christmas barbecue, an evening fun and astronomy under the stars. What else here? So there's for the Saturday from about 2 o'clock in the afternoon, you've got solar viewing, kids activities area, something to do with radio astronomy, kids pop-up activities store, the Leon's Club barbecue, bird life, something to do with bird life at LMSS, botanical tour, a site tour, and also a trivia, a door prize draw of some sort. I haven't been up there for ages to this barbecue. I think the last barbecue I attended was 2019. But many things are going ahead, and it is worth a visit if you're interested in the ASV and seeing what it's all about. All right, let's move along now to the first article I've got here. You're tuned to ASV Radio VK3 EKH with the official broadcast for the ASV. Just checking my email. I see there's an email that's coming from Andrew, VK3KIS. G'day, Andrew. Listening on 80 metres. And Steve, VK3SBX. He says a little bit of QRN is there today. You running QRP today? No, it's 100 watts. Yep, just winding up that, making sure that RF is where it is. So, yep, it's just well, not QRP, but it's not being linear assisted. And if you're listening there, Wayne, acknowledge that too. Not a problem, dear sir. All right, and a quick look at Discord. I don't know if there's anybody there, actually. Where am I? The chat room. Here we are. I see that Cassiopeia is there. Our resident member of the Mount Burnett Observatory is there. G'day, David. And that's all I can see at the moment. And Steve as well on the chat room. So welcome to Discord, chaps, and the video stream as well. All right. There's an image associated with this first article off the bat. That's not it. Where are we? vMix is tricky sometimes. All right. So this is in relation to Starlink. New Starlink satellites could be 32 times brighter in radio waves than before. Now, this is really scary stuff. A recent study found that SpaceX Starlink V2 mini satellites emit more radio waves, potentially interfering with radio astronomy. This is not good. Not good at all. Researchers using the Low Frequency Array, or LOFAR, radio telescope in Europe have discovered the second generation of Starlink satellites emit high levels of radio waves that could pose a serious risk to radio astronomy. This issue of radio wave emission is in addition to the sunlight that Starlink and other satellites reflect, which can be visible to the naked eye and leave light streaks on optical images. In observations taken over the summer, Starlink's V2 Mini, an upgrade model of its internet-providing satellites, emits up to 32 times more unintended electromagnetic radiation, or UEMR, than its predecessor. The LOFAR radio telescope, composed of several antennas across Europe and managed by the Netherlands Institute of Radio Astronomy, Astrom, tracked satellites on July 19 over the course of two 1-hour sessions. The results published in the Journal of Astronomy and Astrophysics on September 18 found that the objects emitted more powerful radio waves than the previous generation, and this issue is brought more to the fact by the V2 Mini satellites operated at a low orbit than previous Starlink satellites. According to LOFAR lead researcher Says Bassa in an Astron news release, these satellites are about 10 million times brighter in radio waves than any faint objects LOFAR could locate. This difference is similar to the faintest stars visible to the naked eye and the brightness of the full moon. Since SpaceX is launching about 40 second-generation Starlink satellites every week, this problem is becoming an increasingly worse situation. SpaceX began launching the V2 Mini generation of satellites early last year as part of the company's Starlink constellation, which offers high-speed internet access across the globe. The satellites incorporate new measures to reduce their reflectivity, helping to mitigate their impact on optical astronomy and naked eye observations. In a release in 2023, the company highlighted its work with astronomers, saying it has prioritized collaboration with astronomers and scientists to mitigate the impact of Starlink satellite streaks on their observations. However, the new results show there is more work to be done to lower their impact on radio astronomy. No kidding. SpaceX did not respond to requests for comment. SpaceX has also worked with the US National Space Foundation, NSF, and the National Radio Astronomy Observatory, NRAO, to reduce their impact on the field, having signed a coordination agreement in 2019. In experiments conducted since 2021 at the Very Large Array in New Mexico, SpaceX and the NRAO have worked on methods to coordinate operations so that Starlink satellites can steer their transmission beams away from operating radio telescopes. However, the radio emission detected in this new study concerns electromagnetic radiation that leaks out from satellites unintentionally. The LOFAR study stated that there are ways to keep these satellites from interfering with radio telescopes. These actions include raising awareness, advocating for radio quiet zones, and stricter industrial regulations. The study states that with this new information, there is hope that SpaceX and Starlink will continue to mitigate UEMR and its impact on astronomy in the future. So, yeah, things are sort of still looking a little bit precarious out there as far as radio astronomy is concerned. Not good at all. And for astronomy in general. All right, you're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. Next on the scheme of things here, I have, this is just a very quick thing. I don't really like to delve onto this really too much, but Americans with how they are. This is courtesy of space.com, and apparently there is still a continued push to release the truth about UFOs, or unidentified anomalous phenomena, UAPs as they are now called. And I'll just draw your attention to space.com where this article is, because I won't go right through the whole thing. But it's titled UFO Whistleblowers Tell Congress We Are Not Alone in the Cosmos. video. There's a video. I said, oh yeah, I've got a little link to that. Not a link, but a picture of this video. These three chaps in business suits, all looking very official. And I did move that across, didn't I? Maybe I didn't. Hang on a sec. Let me just find this image. There it is. And let me just bring it up so there's some sort of reference. Okay, published 2 days ago, excessive secrecy has led to grave misdeeds against loyal civil servants, military personnel and the public, all to hide the fact that we are not alone in the cosmos, is the premise of this article. That image on the screen are three official folks presenting to Congress that and because Trump is now in play, to try and release some of this information that's being kept. Anyway, the US House Representatives Committee on an Oversight and Accountability held a hearing titled Identified Anomalous Phenomena Exposing the Truth at the Rayburn House Office Building in Washington. On Wednesday, the 13th of November, Identified Anomalous Phenomena, or UAP, is a relatively new catch-all term that includes sightings of unexplained objects of events that take place in the air, underwater, in space, or that travel between those domains. Like previous congressional UFO hearings, today's event featured testimony from current US military personnel who claim that the American government has for decades hidden evidence of advanced technologies and otherworldly visitors from the public. A magnitude of anecdotes were presented about flying orbs coming out of the ocean, disc-shaped objects and craft exhibiting flight and structural characteristics unlike anything in our arsenal. While such claims are nothing new, what is noteworthy about today's hearing are the pedigrees of some of the whistleblowers who testified, including a former US counterintelligence officer, a retired US Navy Rear Admiral, and a former NASA associated administrator. You know, the more they bring out these big wigs that claim to all this stuff, the more it gets a bit ridiculous. But anyway, so yeah, there's another push there to try and get information out. And to be honest, I don't know about it really. Anyway, but that was just in space.com. Published just 2 days ago, and I usually do have a little bit of information on that from time to time here on the broadcast, but I don't go into huge super details. All right, noting that the time is moving along here, how quick half an hour goes when you're having fun. Next article that I've got here on the list, this is VK3 Echo Kilo Hotel. This is interesting. I don't think it goes for very long, and there's a kind of a graphic for this, which I'll throw up on the screen as well, so you're not always looking at me. VMix. Okay. Unpredictable solar activity sends satellites plummeting to Earth. 13th of November. Space.com. Was it? No, it's Science Alert. Last week, 3 tiny Australian satellites from Curtin's University Binar Space Program, BINAR, Binar Space Program, burned up in Earth's atmosphere. This was always going to happen. In fact, Binar means fireball in the Noongar language of the First Nations people of Perth. Okay. When a satellite is in low Earth orbit, approximately 2,000 kilometres or less, it experiences orbital decay as it drags closer and closer to the surface, eventually burning up. But these cube satellites, or CubeSats, known as Binar 2, 3 and 4, entered the atmosphere much sooner than originally planned. They only lasted for 2 months, a third of what was expected. This significantly reduced valuable time for science and testing new systems. The reason for their untimely demise? Our sun has kicked into high gear, and the Binar satellites are far from the only casualty. Recent high solar activity has been causing an unexpected headache for satellite operators in the last few years, and it's only increasing. Solar activity includes phenomena such as sunspots, solar flares and solar wind, the stream of charged particles that flows toward Earth. This activity is this activity is a product of the sun's ever-changing magnetic field, and approximately every 11 years it completely flips. At the midpoint of this cycle, solar activity is at its highest. While this cycle is known, specific solar activity is challenging to predict. The dynamics are complex, and the solar forecasting is in its infancy. In the last few months, indicators of solar activity were more than 1.5 times higher than predictions for this point in the current cycle, labelled Solar Cycle 25, which actually I can bring that latest image of that up on the screen. This is where we are in the scheme of things, both in the radio and the optical side of things. That's where we are, roughly. And space weather refers to the environmental effects that originate from outside our atmosphere, mostly the sun, and it affects us on Earth in a variety of noticeable and unnoticeable ways. The most obvious is the presence of auroras. In the past few months, auroras have been visible far more intensely and closer to the equator than the last 2 decades. This is a direct result of the increased solar activity. Space weather and solar activity in particular also creates additional challenges of satellites and satellite operators. Higher solar activity means more solar flares and stronger solar winds, resulting in a higher flux of charged particles that can damage or disrupt electrical components on satellites. It also means an increase in ionization radiation, resulting in a higher dose for astronauts and pilots, and potential disruptions to long-distance radio communications. But for satellites in low Earth orbit, the most consistent effect for solar activity, or of the solar activity, is that extra energy gets absorbed into our outer atmosphere, causing it to balloon outward. As a result, all satellites less than 1,000 kilometers above the Earth experience a significant increase in atmospheric drag. This is a force that disrupts their orbit and causes them all to fall towards the planet's surface. Notably, satellites in this region include the International Space Station and the Starlink constellation. These satellites have thrusters to counteract this effect, but these corrections can be expensive. Low Earth orbit also contains many university satellites, such as the Binar CubeSats. Cube satellites are rarely equipped with tools that can adjust their altitude, so they're entirely at the mercy of space weather. The Binar Space Program is a satellite research program operating out of Curtin University. It aims to advance our understanding of the solar system and lower the barrier of operating in space. The program began operations with its first satellite, Binar 1, in September 2021. This was less than a year into Solar Cycle 25, when solar activity was relatively low. In these conditions, the 10-centimetre cube satellite started at an altitude of 420 kilometres and survived a full 364 days in orbit. The program follow-up mission, Binar 2, 3 and 4, were 3 equally sized CubeSats. However, they were expected to last approximately 6 months, owing to the extra surface area from new deployable solar arrays and a forecast increase in solar activity. Instead, they only made it to 2 months before burning up. While Cube satellite missions are relatively cheap, the premature ending of a mission will always be costly, and this is even more true for commercial satellites, highlighting the need for more accurate space weather forecasting. The good news is the sun will calm down again. Despite the current unexpected high solar activity, it will likely slow down by 2026 and is expected to return to solar minima in 2030. So yes, the things that go on in orbit. Right, get back to this one here. You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, where the time is 22 minutes to 11 roughly. Next on the list, and there's a picture for this one too. Okay, not that one. This image here. This is a quick article. It's an Ask Astro article, astronomy.com. How are long exposure astrophotos made, you might ask? Computerized telescope mounts and plate solving software make it easy to return to the same celestial location every night. This is what I find absolutely fascinating about astrophotography, how you can take multiple images spread out over let's say half a year or so, and you can always come back to exactly where you're looking. The accuracy involved is just stunning. Many astro photos feature exposures of 12 hours or more. Since nighttime darkness is about this long, this implies multiple exposures on different nights. How does one set things up to get the exact same location and avoid parallax error due to Earth's rotation and orbit? Good question. You are correct. Many long exposure astrophotos span multiple nights. The author says, I typically stay on target for months at a time, especially when I'm living in a cloudy place, says the author here. Plus, viewing locations often have a tree or a building or some other obstruction, meaning that many objects are only visible for a few hours per night. And because it is best to image objects that are at least 20 degrees or so above the horizon to avoid the thickest lines of sight through the atmosphere, your window may be further limited. Astrophotos usually consist of dozens to hundreds of multiple minute exposures that are stacked together to reduce noise and bring out the dim celestial object being imaged. The computerized telescope mounts astrophotographers use to track the sky know where to point based on the mount's latitude and longitude and the date and time. With the help of plate solving software that uses star patterns to identify where an image is located in the sky, it is easy to return to the exact same celestial location every night. The effect of parallax, the shifting of nearer stars relative to those farther away from Earth as Earth travels around the Sun, is negligible. The nearest star, Proxima Centauri, only appears to move 0.77 seconds over the course of a year, which is only a few camera pixels with long focal length telescopes and is less than 1 pixel for shorter telescopes. And that's all there is to that article. But yeah, I still find that absolutely fascinating stuff. And that image, what was the text say? This image, this deep image, this deep sky image on the screen is the Large Emission Nebula NGC 7822. It's taken from Dayton, Ohio in America. Comprises a total of 27 hours of exposure time over a span of 4 weeks. which was done in 2022 to get that image. It's pretty good, isn't it? 27 hours of exposure time over a period of 4 weeks to get that. Fascinating stuff. I reckon that's just interesting, very interesting. All right, now the time is 10. I've got to keep an eye on it because I've got Tamitha's video to show. It's only an 8-minute video, but I do want to squeeze that in. I left over an article from last week. Do I have time to go through that? Oh yeah, it's not very long. Okay, this is courtesy of sciencealert.com, and I'll switch the image here while I'm thinking of it. We're going back to Mars. Mars rover finds evidence of an ancient ocean on the red planet, November 8. A Chinese rover has found new evidence to support the theory that Mars was once home to a vast ocean, including tracing some ancient coastline where water may once have lapped, a study said on Thursday. The theory that an ocean covered as much as a third of the red planet's billions of years ago has been a matter of debate between scientists for decades, and one outside researcher expressed some skepticism about the latest findings. In 2021, China's Zhurong rover landed on a plain in the Martian Northern Hemisphere, Utopia region, where previous indications of ancient water had been spotted. It has been probing the red surface ever since, and some new findings from the mission were revealed in a new study in the journal Scientific Reports. And there's another image here, which is more what the article is focused on. What's on the screen right now is the Zhurong landing site, which is marked with a red cross, and regions of different colours indicate different geologic units. The red box shows the study area. Okay, lead study author Bo Wo of the Hong Kong Polytechnic University told AFP that a variety of features suggesting a past ocean had been spotted around Zhurong's landing area, including a pitted cones or polygonal troughs that are etched in flows. Previous research has suggested that the crater-like pitted cones could have come from mud volcanoes and often formed in areas where there have been water or ice. Information from the rover, as well as satellite data and analysis back on Earth, also suggested that a shoreline once was near this area, according to the study. The team of researchers estimated that the ocean was created by flooding nearly 3.7 billion years ago. Then the ocean froze, etching out a coastline before disappearing a little over 3.4 billion years ago, according to the scenario. Bo emphasised that the team does not claim that our findings definitively prove that there was an ocean on Mars. That level of certainty will likely require a mission to bring back some Martian rocks to Earth for a closer look. So to finish off that article, there's one more image here which I should bring up. This one here. One more paragraph, maybe two. Benjamin Cardenas, a scientist who has analysed other evidence of Martian ocean, was also sceptical of the new study. He felt the researchers did not take enough into account how much the strong Martian wind had blown around sediment and worn down rocks over the past few billion years. He says, we tend to think of Mars as being not very active, like the Moon, but it is active, said Cardenas. He pointed to the past modelling research which suggested that even the slow Martian erosion rates would destroy signs of a shoreline over such a long period. Bow acknowledged that the wind might have worn down some rocks, but said the impact of meteors hitting Mars can also excavate underground rock and sediment to the surface from time to time. While the overall theory remains contentious, Cardenas said that he tended to think that there was an ocean on Mars at some stage. Finding out the truth could help unravel a greater mystery, whether Earth is alone in the solar system or being capable of hosting life. Most scientists think life on Earth sprung up either under the oceans, where hot gases and minerals from the subsurface came to the sea floor, or very close to the interface of water and air in little tidal pools, Cardenas said. So evidence for an ocean makes the planet appear more hospitable. Right, so that's courtesy of sciencealert.com. All right, I think at this point, let me just check where I was going to go with the other articles here. Getting back to my list. That can certainly wait till next week. And, yeah. I suppose it can wait till next week. Okay, on that note, let's queue up Tamitha with her latest space weather report and see what she has to say for the weekend coming up. If I can just find the video, there it is. All right, stand by for Tamitha Scove and the Space Weather Woman, 8 minutes, 22 seconds. And let's hope this all works nicely here. Just drop that audio down a bit.
We have a coronal hole with some fast solar wind headed toward Earth and lots of filament eye candy. Those stories and more in the news this week. Space weather this week is calming down comparatively to last week. As we take a look at our Earth-facing disk, we do have lots of active regions in Earth view, but only a few big flare players like region 3889. We've been paying close attention to that region. Most of the eye candy, though, has come from big filaments like this interesting looking number 3 here, and this big worm-like filament as well. We've got a couple other ones that we've been watching, but there just hasn't been any Earth-directed solar storms from these eruptions. In fact, some of the prettiest, like you'll see one launch right here on the 10th. It launches to the south. Whoosh, right there. That was gorgeous, but look at it in coronagraphs. It really is kind of boring. There's not much going on there. We also had a filament eruption. You can watch this little guy right here. This is in the Earth strike zone. Whoosh, right there. But when we look at it in coronagraphs, look at this tiny little thing. Launches off to the east of us, and then that's about it. And that's really all that's been happening this past week when it comes to solar storms. Really, where we're getting the biggest stuff is from this coronal hole right here. We're expected to get some fast solar wind from this extended coronal hole, and that could give us a little bit of aurora that comes down to mid-latitudes over the next couple days, but not much more than that. Meanwhile, as we take back a look at this number 3 that has been rotating through the Earth strike zone, you can watch a gorgeous part of this thing erupt here to the south. Whoosh, look at that. And it was actually quite dazzling in coronagraphs. It's quite dense, but once again, not Earth-directed. Meanwhile, as we go back to the disk, we had another gorgeous eruption off of the west limb. You can see it coming up right about here. Whoosh, right there. That was a gorgeous eruption, but again, in coronagraphs, beautiful, but not Earth-directed. So we've really been dealing with that over and over again. Really, it's turning into getting some activity from coronal holes. And as you look to the east part of the disk, really not any big active regions to kind of replace the activity that we've been seeing here. So solar flux has been dimming down and things are getting quieter, but as we take a look at the sun's far side, we'll pull up our JSOC HMI helioseismology far-sighted viewer, and that actually shows us that the active regions that gave us a lot of activity just last week at the end of October, these regions have now rotated to the sun's far side, and region 3869, 3872, and even region 3868 These regions, look at this, look at all this darkness right here. These regions look like they're surviving their far-sighted passage. So in the next 3 to 4 days, and that's along with even region 38, 24, or 74 rather, these regions could be rotating back into Earth view with a vengeance over the next 4 days or maybe a little bit longer. And that means X-flares could be back on the menu with R3 level radio blackouts and the potential for more big solar storms. Switching to our moon, we are now passing through the full moon phase, with the full moon being on the 15th. And by the 20th, the moon will still be about 75% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, like, I don't know, maybe some aurora or the Leonid meteor shower that should be peaking right around the 17th, well, you're going to have this bright companion, so you're going to need to check your local rise and set times. Now, switching to our solar storm conditions and aurora possibilities over the coming week, we are anticipating the fast solar wind from that corona hole that's rotating in through the Earth's strike zone. So at high latitudes, NOAA's expecting minor storm conditions. In fact, they expect about a 50% chance of a major storm at high latitudes. And this should last from Thursday into Friday, with things kind of calming down as we move into the weekend. That's assuming we're not getting any more solar storms. So aurora photographers, enjoy a nice view over the next few days and expect things to settle down. And then as we move into mid-latitudes, well, the story's about the same. We're expecting active conditions with up to about a 20% chance of a minor storm at mid-latitudes. And then things again will settle down by the 16th. We should be back to unsettled conditions, and we should have a few days of rest before we start looking for new solar storm potential on the sun's east limb. And now switching to our solar flare and dayside radio blackout outlook over the coming week, we are still sitting well in the triple digits for solar flux, and this means dayside radio propagation is doing quite well. However, you notice that the numbers have dropped dramatically, and that's because we don't have as many active regions in Earth view, nor do we have as many big flare players. This luckily means the noise level has dropped from severe to moderate range, and this is likely going to continue over the next few days, possibly throughout the week, until new regions begin to rotate into Earth view in about 4 days. Now, NOAA's getting us about a 60% chance of M-class flares. This is at the R1 to R2 level radio blackout, and also about a 20% chance of X-class flares. That's at the R3 level radio blackout. But expect that risk to kind of dim down just a little bit, especially in through the weekend, before things begin to pick up once we start seeing those new regions rotate into Earth view on the east limb. So you amateur radio operators and emergency responders, well, all I can say is enjoy the quiet. And now switching to our radiation storm and polar aviation outlook over the coming week. Everything is in the green this week. We are at the D1 normal range. This is at flight level 360 for you aviators. It's also the S0 quiet range for everyone else. We are expecting about a 10% chance for an S1 to S2 radiation storm, and this is going to continue throughout the next 3 days, with the risk rising just a little bit as region 3889 rotates to the sun's west limb. That's the region that's actually been giving us a bit of a threat in terms of radiation storms, but everything else is pretty quiet. So you frequent flyers, and this does include air crew and you high-risk passengers, you're all in the green this week, and likely everything's going to stay that way. So the space weather this week is quieted down a bit compared to last week. Now we do have some solar storming expected, but it's mainly from some fast solar wind from a coronal hole that's going to be rotating through the Earth strike zone here over the next couple days. Expect to get a little bit of a show of aurora at high latitudes over the next couple days, but likely at mid latitudes it's just going to be kind of touch and go. So aurora photographers, well, only if you're dedicated should you chase. And now amateur radio operators and emergency responders, while that solar flux has dipped down a little bit, but we're still well in the triple digits, so radio propagation on Earth's dayside should be good. You should also notice that the noise level on the dayside radio bands has also diminished somewhat, as well as less long duration, big radio blackouts. So enjoy this quiet over this next week, because that's about as long as it's going to last before things start getting noisy again as new regions rotate into Earth view. And now for you GPS users, well, things are looking reasonably good for you. We've kind of quieted down on the day side. We don't have as many radio blackouts. And on the night side, we really haven't been having any huge solar storms. We just have a bit of fast solar wind that's coming over the next couple days. So from mild solar storming is expected. So as long as you stay away from aurora and stay vigilant near dawn and dusk, well, your GPS reception should be pretty nice. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
You're tuned to VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South.
Right. Thank you, Rolf. Thank you, Tamitha. A little bit more audio there. 1, 2, 3, 4, 5. Such different audio levels I've got here between video and live, so making sure I keep everything light here. All right, well, that was most interesting, and so this weekend is looking pretty interesting. As I sit here looking through my shack window, I can see the full moon through the window. It's quite interesting to see that. So we just have a few little other things here to throw into the mix. Andrew, VK3KIS, if you're listening there, I've just sent you an email in relation to that link, the Discord link. What was I going to go into? Spaceweather.com. Yes, it's coming up. Oh yeah. Now, all right. Just a little bit of a plug for the Mount Burnett Observatory. I'll just see if I can bring up the shot that I've got here. All right. Now, interestingly enough, if I had have known this last week, I would have given them a plug last Friday. But tonight they had a guest speaker, and it would have been interesting to have been there. Yes, Members' Night at the Observatory. Special guest Randall Waith was slated for a presentation tonight. Now, the printing's a little bit hard to read here. It's against a white screen, but where are we? Where can I start here very quickly? The title of the presentation is the Square Kilometre Array Low Frequency Array, building the world's most sensitive low-frequency radio telescope in Western Australia. The SKA Low Radio Telescope, low-frequency telescope, is Australia's part of the International SKA Observatory Mega Science Project. SKA Low promises to be a transformative radio telescope and will address the most interesting and pressing problems in astrophysics. Construction of the SKLO is well underway in Western Australia. In this talk, the Randall will give an overview of the SKLO and the key science goals and an update on the latest progress. Randall is a radio astronomer with a background in computer science and electrical engineering. As a scientist with a technical background, Randall bridges the gap between the science and engineering communities, works on novel ways to use radio telescope instrumentation. He has worked as the principal engineer of the astrophysical interests ranging from dark matter through to the birth of the first stars and galaxies. Randall has technical expertise in radio telescope design, digital signal processing, high performance computing, and radio engineering, and has designed, commissioned, and generated science from several radio telescope instruments and arrays. In July 2024, Randall joined the Square Kilometre Array organisation as a senior commissioning scientist for the SKA Low. How interesting that would have been to have been in that presentation there. I'm sad that I didn't get to see this last week to give that a bit of a plug. And that would have been very interesting to have sat in on. So that's the Melbourne MBO, the Mount Burnett Observatory. You can find out more information from Mount Burnett and what they do. They meet generally every Friday night. But just go to the go to the website, mbo.org.au, MBO, Mount Burnett Observatory, mbo.org.au for more information. Yes, they're doing great things up there, those folks. It's only a 22-minute drive from here in Narre Warren South. And also a quick plug for astrophys.com. I've got just a quick image here. I'm running a little bit over time. Not that it's too much of a worry, but I've got one more image here. Where is she? There she is. Brendan has interviewed yet another scientist, Dr. Alina Hyde, and her interview and colleagues, the York Universe podcast. Anyway, I've got a little bit there to read up on. Elena speaks 4 languages, has 4 undergraduate degrees in astronomy, physics, optical engineering and planetary sciences, 2 master's degrees in engineering and astronomy and astrophysics, and a PhD in astronomy and physics. Can't get any better than that. Now, back then, Dr. Hyde was an postdoc research fellow at the Western Sydney University and a data science consultant, and right now she is at work at the York University at Toronto, Canada, where she is the director. I'm not sure what this is. Director PF, the Alan I. Carswell Observatory. I don't know what all that means, but anyway, and is an associate professor who has also developed wonderful outreach programs. One aspect of Eleanor's outreach repertoire is where Doc Hyde and her York University colleagues regularly produce fabulous podcast. In this episode, we are rebroadcasting today. They take us on a deep dive into science and science fiction with space launches from the past. So join Eleanor and her co-hosts, as well as Professor Mary Helen Amor, for this literal blast into space. So that's Astrophys 204, episode 204. And you can find that by just typing in Astrophys, P-H-I-Z, astrophys.com, and Dr. Eleanor Hyde, which is up, you can see on the screen there. So plug there for you there, Brendan, if you're listening there. Okay, I think that's about it. We'll just quickly go to spaceweather.com. And there we go. So the solar wind is currently at 389.8 kilometres a second. It is blowing a gale. Density of 1.58 protons per cubic centimetre. You can see the current disk of the sun. There's only less than a handful of sunspots there. But that is the current disk of the sun, if we were able to see it. The sunspot number is 96. And the radio sun, measured at a wavelength of 10.7 centimetres, is, 147. 147 solar flux units is the radio sun. The aurora, there is some auroral activity going on. This is the current auroral glow over Antarctica. If you were down in Tasmania, I think you'd probably be seeing some evidence on the southern horizon, I would say, looking at that. Also, what else is there? And of course, I just made mention of the full moon through my window here. Spaceweather.com makes mention of this. They say tonight's full moon is a stupid moon. I've never heard of that expression, but that's the Americans for you. They say here that you read that right. Tonight's full moon is a supermoon, or maybe that's why it looks larger than normal. Okay, I didn't know that. Tonight's full moon is a supermoon for the 4th month in a row. We've decided that that's a stupid moon. Supermoons should be special, not repetitive. The term supermoon was coined by an astrologer in 1979 to describe a rare full moon unusually close to perigee, closest approach to Earth, as much as 14% wider and 14% wider and 30% brighter than the ordinary full moons. Now, mainstream news outlets reports 3 to 4 supermoons every year. That's just insert your own adjective with a moon photo. Oh, okay, didn't need to read that out. But anyway, all right, so it's a super moon up there tonight. That's why it's so obvious through my window at the moment. And just one other thing. I haven't read this, but this looks potentially interesting. A rare sine wave in the magnetosphere. There's a graph here that I need to bring up to illustrate here. Okay. Imagine you are at a hard rock concert. Waves of heavy metal crash against your eardrums. You can barely hear a thing. Then suddenly the delicate trill of flute cuts through the cacophony. Something like that happened to Stuart Green of Lancashire, UK, during the severe geomagnetic storm on October 10, 2024. He says, my backyard magnetogram was a riot. He says, but when I took a closer look, there was a delicate wave riding on top of the noise. All right, just looking at the screen there. He says that Green detected a rare pulsation continuous, or a PC wave for short. This is research jargon, meaning essentially a pure sine wave. In the magnetosphere, PC waves are classified into 5 types, depending on their frequency. Green's specimens are PC1 and PC2. And there's a bit more of a detailed shot here of this sine wave that was detected. You can see it in the screen, in the graph that's on the screen right now. You can see the part that's circled or ovaled. So we magnified that up, and this is how it looks. So they go on to say, well, so what? These particular waves matter because they can help satellites survive severe space storms. Fast PC1 and PC2 waves scatter killer electrons out of the Van Allen radiation belts, making the region safer for satellites that orbit through the belts when they are supercharged by solar activity. And then the last thing here is, would you like to monitor the magnetosphere of rare waves? Stuart Green's backyard magnetometer is a great DIY project. Okay, so there's a link there. If you go to the currentspaceweather.com, currentspaceweather.com, they provide a link to that project, the magnetometer. So I'll go investigate that a little bit later on, I think. All right. I think the final thing I go on to here is just bring up my camera. Right. And as of November the 15th, 2024, there were 2,349 potentially hazardous asteroids, but none of those asteroids are on a collision with Earth. I think it's been 2,349 now for quite a few months. That figure hasn't really changed much. It's almost not worth saying. Okay, that's spaceweather.com from the website. So on that, I think we'll conclude our session tonight. One quick look at the sky at LMDSS. This is the all-sky camera. For those that are watching YouTube, which seems to have hung in there tonight nicely. And for those watching Discord, this is a live image from the Leon Mao Dark Sky site just north of Heathcote. You can see how the full moon is really lighting up a lot of objects there. You can see our dish. The 8.5 metre radio telescope dish is in full view at the bottom of the screen there. And I think for general astronomy, it's a little bit difficult with the full moon like that at the moment. So it really does make, if you're interested in doing lunar photography, it's probably the night for that. But that's our current view up at the Dark Sky site, which there is some activity up there this weekend. I'm not sure what it was exactly, but the Starbecue is the one to look out for. Excuse me, on the 30th of November. So to find out more information about that, just visit the ASV website at www.asv.org.au for more information. I think as soon as I'm finished here tonight, I'll run this presentation that was done last Monday again, the Cosmic Catastrophes by Dr. Sarah Webb. It only goes for 45 minutes, so I'll just run that through for those that missed it on Monday and happen to be still up. So, on that note, I shall now go across to our prime frequency, getting my pen and paper ready, making sure my pen works. Yep. And where's my mix? I always like to run a little bit of audio across to things. I think that's it there. Yep. I should mark it. All right, this is VK, excuse me, this is VK3 EKH listening on 3541 kHz for any stations wishing to check in.
VK3GL.
There's a couple of stations that doubled there. VK3GL, I think it was Alpha Fox Delta, VK3 AFD, and but there was somebody else in there. Who was that?
VK3 SPX.
Oh, yeah.
VK3 Golf Fox Delta.
Okay, VK3 Golf Fox Delta, I think it was GFD. All right, VK3GL, VK3SPX, VK3GFD. Is there anybody else? It's a quiet night. Everybody's getting ready for the Hamfest, which is not tomorrow, it's Sunday. Take a Grey, VK3 Golf Lima in Bunyip, VK3 EKH.
Yes, very good evening, Eclipse, VK3 EKH, and those who checked in tonight, VK3GL. Good to hear you on tonight there, Clint, with the broadcast. A good broadcast once again. I did listen to a fair amount of it on the Discord screen. We've had some issues, some IT issues with work this evening. Our system's been offline for about 6 hours. Would you believe it's only just starting to come, well, would appear to be starting to come back on board right now, so I don't know whether or not we've got all of our applications back online yet. But anyway, enough of all of that. Thanks for the broadcast. Yes, I watched a fair amount of it, and particular interest when you were mentioning about the low orbit satellites, etc. I'm wondering if you may or may not know, maybe someone else might know, is there someone who or somebody that manages internationally what goes up in space? So, we can understand that, Elon Musk has gone and put all these Starlink satellites up there, and they're buzzing around the place, and every second week there's another lot of them going up there. Who controls all of that? Because as you said, there's some concerns about what it's going to do from an astronomy perspective. If there's more and more of this stuff up there, there's more and more stuff that's got to be dodged to try and get, I suppose all it's doing is just putting a layer around Earth, isn't it? That from an astronomy point of view, you wouldn't be very happy if you had a bloody satellite in the way when you're trying to study something or receive some sort of a signal, whatever, from deep space, and you got a bloody Elon Musk's Starlink happens to buzz by, a bit of a nuisance. So you might like to tell me about that. I'm not sure if you know. And the other side of it, how does one stop some of these other countries that could perhaps be a little bit rogue from just going putting their own bloody satellites up there without telling anyone? I suppose that's a bit of a problem as well. Anyway, yeah, you're a good signal on 80 metres tonight, good 30 over 9. I noted Tamitha's comment there on her update to say that, you know, maybe there might be good conditions during daylight hours, but my observation on HF is it's been pretty poor for now for probably best part of a week or more. Hasn't been much activity at all, and bands have been quite down. Even 20 metres has been a bit flat. You know, Europe into the afternoons has been quite flat. Signals have been there, but certainly not as much activity as what there was a couple of weeks ago. So there's some interesting conditions at the moment. All right, well, put it back to you there, Clint, and thanks again for the broadcast. Much appreciated. VK3EKH, VK3GL.
Yeah, VK3GL. VK3EKH returning. Okay, on the questions there. I can't immediately tell you at the top of my head any particular, but I do know that the Americans do have they do monitor what's up there in orbit. They have to because it is quite cluttered up there now, and that mob that do monitor what's in orbit are also pretty much involved through NASA with NASA. What gets launched, because as you say, you can't just the various groups around the world that are now launching satellites into orbit. They need to work with other countries that have got other objects or satellites in orbit. So there are some central bodies that do coordinate objects in orbit. There has to be some sort of group that does organise that, and I know there is something in America. There's some might even be in Canada. I need to just find out who it is exactly that does look after all that. But I know there is a group that do monitor what's happening in orbit, and also I suspect call the shots when it comes to how objects get put into space. So, you know, if the Chinese want to launch a bunch of satellites into orbit, and you know how rogue they can be sometimes, those scientists that are involved with those launches, they would I would suspect that they would know that to keep the peace with other countries, they would need to know where can we launch our satellites so that we don't go bumping into other satellites. So there is a group, a coordinating group that do monitor what's up there in orbit, and at the same time provide the necessary information for those satellites where they're going to be parked. I think there is a risk of some rogue countries that could launch their own satellite systems and willy-nilly, but it'd be stupid to do that on the risk that there could be collisions with other satellites. Yeah, I think you'll find that anybody who's got a system set up where they can launch satellites into space from their own backyard, so to speak, they would need to speak to other authorities and administrations to know that they can do that. But I'm not really sure who they are called. I have mentioned it from time to time here of this organisation, and I'm pretty certain it's American-based. Could be NASA-based. All right. Yes, you're a good signal yourself. You're 20. Actually, you're around 30 over 9 tonight, so you're doing very well. All right. I think that's it. Steve, VK3SBX, VK3EKH.
New South Wales. So,
Yeah, I can hear it.
Yeah, interesting stuff as usual, Clint. Yeah, I'm a bit amazed about the lack of appropriate regulations for EMR on these Starlink satellites. I wonder whether or not either Elon just kind of makes it up and he doesn't have to get his stuff tested like most people constructing electronic apparatus do, as I've had to go through before, get stuff formally tested in a laboratory for unwanted electromagnetic radiation, or perhaps the requirements of EMR were underestimated. So I don't know. Yeah, but it's disappointing, isn't it? Because it's such an obvious problem. Obviously, they're going to transmit, but they should stick to their own frequency, you would think. Yes, anyway, never mind. Yes, and the WA sat's getting burned up in the atmosphere. Well, that was a bit of a shame. It doesn't happen to more Starlink satellites. Anyway, I was going to be doing a bit more astrophotography, but the supermoon at the moment has just ruled that out completely. I was trying to get more data on that Helix nebula I showed you a couple of weeks ago, Clint, so I still haven't got the necessary data on that to put it together, but I will at some time soon. And just finally, I just watched a YouTube video about Gilmore Space, the space outfit up there in Queensland, and they're just about ready to launch their rocket to low Earth orbit for satellites and what have you. It's just amazing outfit up there in Queensland. So I thought maybe might be a good subject for another talk at some point. All right, thanks very much, Clint. We'll see you again soon. VK3EKH, VK3SPX.
Yeah, thanks, Steve. VK3SPX, VK3EKH. Yeah, I'll